Sorry. Hi, everyone. Okay. Good evening and good afternoon, wherever you're joining us from. Today is going to be another day in our series, and we have one of the best speaker in the world, one of the most experienced speaker in the person of Moses Ashang. Moses, I hope I'm right with the name.
Yeah, you're very correct. You're very correct.
And Moses has over 7 years of experience. He is a senior cloud infrastructure and security professional with over 7 years of experience designing. He's experienced in designing and securing Azure on multi-cloud platforms. His work focuses on cloud control, plane security, identity-driven access models, secure automation, and zero trust architectures across regulated and high-impact environments. He is an active contributor to the cloud community through published articles and speaking engagement, such as this, and with a strong focus on bridging the gap between theory and real world implementation. Moses is particularly interested in how pipelines, API, and automation reshape the modern security perimeter and how teams can secure these layers without slowing delivery. As you can hear me speak and read out the speaker's profile, it means that there are a lot in stock for us today. And by the way, just before the Azure control plan. And if you have been following the Azure Nigeria community, you must be aware that we have been running this series for the past like 1 month right now. And today is one of the best topics that you can't afford to miss. And I will not do much of the talking. I will just move straight to giving Moses the opportunity to deliver what he has for us, which I believe it's in stock. And I'm going to pick up my laptop and stay behind the scenes to learn today. I hope you also do so. And in the meantime, feel free to drop a chat introducing where you're joining us from. And also, as the speaker is going to present, if I have questions, feel free to drop in the chat. I'll do well to bring that to the speaker. Moses, welcome to the section
Hi,
today.
thank you for having me.
Good, good to have you, and I hope we are going to enjoy your section. And if you can maybe take just like 2 minutes, just tell me what to expect, what I should expect out of this section today, and the audience and all that, so we'll be able to know briefly what do you think
hmm
the audience is going to learn from your section today.
Well, yeah, I think the major thing, which is most important to me at this point, would be to introduce the audience to the concept of reliability and security on the control plane itself. We do a lot
Okay.
of work generally as cloud people around the cloud itself, but sometimes we do not understand there's a differentiation between the identity management control and the data plane. And so I'm trying to show that difference, show how security
Yeah.
matters in implementing across each of these planes, because as much as we enjoy what we do by building and designing infrastructure, we should also understand how to secure it properly. So our core aim here today would be to learn how best to secure infrastructure based on which of the cloud planes they exist on. What are the
Yeah.
new perimeters that we should be looking at in the cloud? Because the cloud has transitioned, or IT journey has transitioned from on-premise to the cloud and things like that. So I'm going to
Yeah.
show that transition, the perimeters that have existed are now existing because of that transition, and how else to proceed with all these changes and best way to secure and move forward with things like that.
Okay, thank you very much. The floor is yours right now, Moses.
Thank you very much. Thank you so much. And that was such a wonderful introduction. I really appreciate that. So I'd be sharing my screen now. Hi everyone. I trust you are having a wonderful day. So I will be sharing my screen basically now, and please do let me know if at any point you feel like I am moving too fast or you need me to slow down, and I'll be more than happy to slow down because sometimes I get in the groove and I get carried away. So the topic today is rethinking the perimeter, zero trust at the Azure control plane. This is a very pertinent topic or very important topic because the cloud in itself is a beautiful thing. It gives us the opportunity to design, to build infrastructure, to build workload, to save cost, and to run scalable workloads across multiple sides of the cloud. or even multiple systems, from virtual machines to containers to networking and things like that. It generally allows us to do a lot of things. But as we know, security is a key aspect of every part of the cloud or every part of every service. So for that reason, we're having this session basically to pinpoint or to point out some important sides to the cloud, why this is important, and how best we'll be able to secure or design certain services to make sure they are reliable, they are scalable, and they're very available. So work with me on this journey. First thing I like to say is cloud breaches generally do not start from an open port. They start with identity hijack. That's a very important statement that a lot of times, if you look at it critically, you'd realize two things. The first thing you'd realize is that it doesn't start with a port. And we know port has to do with networking and also workloads like virtual machines or even applications or servers that hold services. And then it starts with an identity hijack. Why is an identity so important? And why is the port also so important in this instance? With this, I'm going to try to explain the concept of the cloud transition from on-premise to the cloud, how the perimeter for defense of the cloud has shifted from networking, I'll call it perimeter security, to identity security or identity perimeter. Work with me as we go through this journey and let's see how else we go. Traditional perimeters in the cloud has always been around designing services to ensure that we're able to block intruders based on specific criteria. For example, firewalls, VPNs, network segmentation. We typically would say when you build a service, when you have an application or a web service or anything, we always consider how do I prevent an intruder from getting into this system by firstly putting up a firewall. After putting up a firewall, next thing you want to do is ensure VPN connectivity is the only way to access those services. So you want to say you can only connect using virtual private networks and things like that. And then you go into the design layer and start saying you want to do network segmentation. But if you actually think about this, you'd realize that what you are doing is you are doing on-premise security thinking, or you are securing your infrastructure like you are still on-premise. Remember when you were on-premise, the key things was to ensure that your data center is safe, to ensure that services or people coming to access your server or your service have to go through a defined path. And then we always put in a firewall. We wanted to always give access to specific services. Maybe there was only on that service is only available based on specific IP addresses. So maybe on our private network. And so we use VPNs. And because we had so many services running, we always went to continue things using network segmentation. So we wanted to ensure that our application A is not interacting with application B because they are on defined network paths, and then specific ports are what is open, and only services can reach certain things based on where they exist, what access they have, or what direction they have to that port. Do they have VPN access? And also, is the firewall reviewing this request to check for specific things? But because we have moved to the cloud, all our workloads are now readily accessible. So why this is still important, there's now more important things that have come up. For example, how do we access these resources? Who makes deployment? How is deployment done? Remember when you were on premise, deployment was done from VPN connections. You had to have specific control access to that service, but we never really had role-based access control. We never had things like Entra. Even though we had identity managers like Active Directory, we never really had things like Entra, which is the cloud version of identity in itself. RBAC, APIs, and service principals. All of these are now cloud realities that have made most of these perimeter security systems to be obsolete. And because the systems are obsolete, we have to think what is the best way to protect our new services? What is the best way to protect our cloud services from these same malicious users we've been trying to prevent on premise? I remember as we have grown, so have these attackers grown. Because we moved from on premise to the cloud, the attackers thinking have also moved from on premise to the cloud. And that is why I like to say we have to look at the cloud from a cloud perimeter, create a new perimeter for the cloud. What has changed? Why is the cloud perimeter now more important than ever? And why traditional thinking will not let us work optimally or secure our services optimally using the cloud. So if you look here, you see the part that I said network perimeter versus identity perimeter. Identity perimeter, what does this entail? If you readily work with the cloud, I do a lot of us do, you would know that most of this points you towards the identity side of the cloud. But remember, like I said, security in the cloud goes beyond even identity. But remember, There's so many sides to it. And so we're going to focus on one side today, but ensure that we make the most out of it and build off of all of that. The control plane model. From our topic, it said that securing zero trust at the control plane. I'm going to try to explain what the control plane is. But before I do that, I want to explain what other planes do we have? How do they work? We have the Azure plane model. Azure is typically broken down into three planes. We have the identity plane, we have the control plane, and we have the data plane. The identity plane or the management plane is what we call our intra services, things that gives us access to make changes. This can be controlled by us, yes. But why are they so important? You know how important identity and intra is on Azure or on the cloud generally. And so for this reason, we need to have a structured plane where all of these changes, or we can manage those services. That is where the identity plane comes in. The control plane. The control plane, which is the core focus of this study here, or this session basically, would be explaining how the control plane is the middleman and the heart of Azure in itself. The Azure control plane is Azure Resource Manager, which is like, no, I'll say Azure Resource Manager is the heartbeat of the Azure control plane. The Azure control plane is that layer of Azure where we make distributions, where we make API calls, where we make checks. For example, if I go to the Azure portal and I say create a new service or create a VM or something, who is creating that VM? What service is making that creation? All of that is done on the Azure control plane. The control plane then checks, should I be running this service? Should this user have access to making this change? Should this user be able to create, delete, or update resources? Should this user have the permissions to give assessment or role-based control to other users? Is this user allowed to make policy management? Does this user's action match our policies? And does this user have the access to make subscription level changes? That is where the control plane comes in. I'll go a bit further and say the control plane is the part of Azure that we call even when we use our DevOps pipeline. Why is the control plane so important? You see when we move on to the next slide. Before I move to the next slide, I'll talk about the data plane. The data plane is that plane on the Azure where we make consumption of the workloads. For example, you want to pull a secret from a key vault. You want to make changes to an app service secret itself, not the service behind the app service secret. You want to consume things from storage accounts. You want to consume things from SQL instances, things like that. That is where the data plane comes in. So the data plane is the plane that holds your workload, where your SQL services run on, where the data on your storage account runs on. So, for example, if I was to list keys on a key vault, that is a data plane action. Whereas if I was to create a key vault, that is a data plane action. So why is this important? It's important also for security point of view because how you secure the data plane is different from how you secure the control plane. I'll hold on and say something. Consider what's it called contributor access on Azure, RBAC, contributor access. What access or what controls the contributor access give you in Azure, as against what access the contributor access gives you on a resource level? That is a very good differentiator between control plane and data plane. An example, what I'm trying to explain. Control plane would be saying contributor access on a subscription means you're allowed to make subscription level changes that will impact all the services in Azure. It can give you permission to create, can give permission to delete, can give permission to update and things like that. But if I was to give you, say, Key Vault Manager, Key Vault Manager role will allow you only manage resources in the Key Vault, not delete it, not update it, but manage the resources in the Key Vault. So basically, the data plane allows you to consume data in that service, while the control plane allows you to make control level changes like create, delete, or update services, policy management, and all of that. So I hope this gives you a little more insight as to what control plane versus data plane is and why these planes are important in themselves. Next slide would also show this. So this is a very key example. It says the control plane is where your infrastructure is defined. If an attacker owns your control plane, they own everything. Like I said, imagine an attacker owner permission on your subscription, it means that attacker can give themselves any role they want. They can give to whomever they want. They can make infrastructure level changes, delete, update, create whatever they choose to do on your services. They can even create backdoor accounts for themselves, take data if they want to, reconfigure resources, and destroy your environment if they choose to. And so that is why it is very important that we look at security on that plane level. Remember, there's the control plane, there's the data plane. The data plane is the consumption level of your data, while the control plane is the plane that allows you to make actual changes on services and on data. So I'll go forward one more step and say, how do attackers actually abuse the control plane? Because remember, the control plane is quite important. Attackers have also changed their pattern. um think about it this way: if you were an attacker, what would make more sense to you? Would you rather be able to make subscription level changes, have access to the resource itself, and then decide to extract data or whatever you choose to from the entire control plane itself? Or would you rather spend all that time focusing on one application, trying to find source spots and all of that? Attackers have changed their mindset. They now realize that the actual power is beyond port scanning and all of that. Now they are focused on how do we access control plane of specific environments. And so I'm going to try and walk us through how attackers focus on these planes, how they're able to get access to these planes and things like that. I'll start with service principal compromise. Why is service principal compromise such a big deal? We know what service principals are. We know how important our service principals are. Service principals allows us to make connections between services. For example, connections between applications to other applications, from third-party services to applications, and things like that. What access or what level of access do these service principals have? And what would happen if a service principal is compromised? Is something we should always look at, or something we should always consider. And for this reason, we'll look at. I'll try and not spend too much time explaining all of this, because we're still going to go a step further and explain how this compromise, the workflow goes on these compromises or on these services. So give me just 1 minute to focus on service principles. Service principals, we know they are non-human identities, and they allow us to get access to application level things. For example, they allow us to make change, they allow us to make connections between services, they allow us to authenticate, they allow us to use automations for authentication. When we use service principals in itself, we do not need to make MFA compulsory anymore, because we can then allow workloads to speak to each other. Non-human identities, a virtual machine and another virtual machine, our DevOps pipeline and our control plane in itself. For example, how do we even connect from our DevOps pipeline to our control plane when you try to deploy services? We do all of this using service principals, using managed identities and things like that. Yeah. So this is where service principal comes in. Now, what happens if a service principal is compromised? How do service principals get compromised? I want us to think about that for a second. Think of all the times you have unintentionally put in secrets for your service principals in your DevOps pipeline, or all the times you have unintentionally saved your service principals, the secrets of your service principal in a notepad on your laptop. What if there was a compromise on your laptop and you don't know, or there's a service or someone scanning your laptop? How are you sure that they have not had access to those secrets or client certificates that you use for these service principals? Things like that. So I'll give like a rundown of how this should work, or how attackers would abuse the control plane. Let's assume that an attacker gets access to your client secret, maybe through scanning GitHub repos or scanning DevOps pipeline, or maybe even your device in itself is compromised. And then the attacker finds access to this service. Now that the attacker has access, or he knows your secrets, he's able to call the ARM intended Azure Resource Manager, which is the module that manages, or like I said, the heartbeat of the control plane. Meaning that that attacker has the ability to, one, use your credential to authenticate with that service principal. Remember, we don't use MFAs when we use service principals because they are non-human identities. So we don't use MFAs. Now the attacker has your client secrets, or has some kind of environment variable that you use your secret for. And so he can call your environment, he can list out things in your environment, he can even go as much as escalate his privilege now that he knows that he has the access. Remember that service principals last for a long period of time, because The secrets we give to service principals, we generally will give it for maybe 3 months, 90 days, 1 year, sometimes even 2 years, because we are trying not to break the process as frequently as possible. So what happens if that is compromised? Because when you copy the initial client secrets, you put it somewhere, or you even unintentionally put it in your pipeline itself, or you stored it in your GitHub repo in itself, and now someone has access to it and they can make calls to that. That is one way attacker can make use of this and escalate permission and do whatever they choose to do with your service principal. Attackers are actually very, very concerned right now with getting access to your service principal, because that's like one of the easiest way to run permissions, because service principal will be given broad permissions, for example, like contributor access or things like that. Another way is access token theft, and then they replay this access token. How do access token theft happen? When we make connections between services, or when we make connections to maybe even the portal, remember we are using access tokens that typically last for an hour. And these access tokens can be reviewed by someone who knows what exactly they are looking for. Think of things like maybe man in the middle attack. Think of maybe you have a compromised browser, or you have a third party service running on your GitHub. And in your GitHub repo, this third party service is compromised and can review the services you are running. What happens to this GitHub repo? I'm so sorry about that. What happens to this GitHub repo? What happens to these services that are running? I'll give a good example would be, we usually always enable third-party services. Well, not third party, but usually when you go to your Visual Studio, you'd most likely have a third-party service running, because it makes coding easy for you. It makes you to be able to run Terraform on an easier level. It allows you to spot errors quickly. But what if these third-party services are compromised, and someone in that chain is able to replay or take your access token? It means they have 1 hour to do as they wish with your access token. In that 1 hour, they can compromise your pipeline. They can exploit SSRFs, what do you call them? Server-side request forgeries. They can make changes to your applications, to your VMs, to your services in itself, and extract your tokens. And once they're able to extract your tokens, they can do dangerous things to your environment. I know that kind of explains it. Think about it this way. We have personal access tokens on GitHub or on our repos. And our repos personal access token allows us to make specific calls directly to the pipelines themselves. We can download the pipelines. As a security person, we always try to even block personal access tokens and ensure we're only using Azure DevOps access tokens themselves. Now, imagine someone has access to that token, means they have access to your environment. They know what you are deploying. They know how you are deploying what you are deploying, meaning that they can run through your environment because you are not going through MFA again. And now they have direct access to the environment, which is a very big risk. And so attackers generally always target things like access tokens, using man in the middle attacks, using things like SSRS, and basically even your web browser. They could also be malicious code in it, just looking for your access tokens and things like that. Another thing would be pipelines and CI/CD abuse. We know our pipelines are built to deploy services directly to Azure. So we do not have an extra layer of authentication in those pipelines. So our pipelines are directly connected from our services straight to the Azure control plane. We do is we have service principals, we have secret keys that expire maybe after 1 year, expire maybe after 6 months. It's typically always 1 year, Dubo. We have this 1 year service principals that these service keys that last for about a year. And so every time every time we renew those keys, it means that there's a possibility that those keys could have been exposed. We might have been careful about it, which is good, but there's that possibility. So it means that we also need to consider what is happening. How are we sure no one's going to inject malicious code to our repos? How are we sure that our pipelines are not compromised? Even a step further, our pipelines, we usually have third-party services running as gates in our pipelines. We have things like, I'm not going to mention specific provider, but we have services that are there to check security, services that are there to check that we're using appropriate lines of code, services that are there to check to see that we don't have malicious code being put in our code. Now, how are we sure that these third-party services that we have no control over have not been infiltrated one way or the other? We do not know that. And so we have to build and design with the mindset that there's already a compromise. And what I'm trying to point out in this instance basically is to show that in the cloud services in itself, or even anyhow you make your connection, there's a likelihood that changes can be made by someone who doesn't know, who shouldn't have access to your environment. So exploitations can happen because of misconfigured pipelines. Exploitations can happen because someone somewhere put up the access tokens unknowingly to the public internet. So these are ways that attackers are able to make use of your environment or even get access to your environment and make control plane level changes. Another is privilege escalation. We know that we should always be careful with the kind of access we give. We should always be careful with the kind of permissions we give to people generally or even services themselves. So who should have access to the environment should be tied to specific users. What kind of access they should have should be tied to specific users. But attackers now, what if they had access to a specific user account now? It means that they are that user and they can inherit this privilege that that user has. And remember, we should always give least privilege, make use of things like PIM, just so that in the event that the account is compromised, we're able to reduce the blast radius. But in this instance, we're still speaking about how these manipulations happen and how we can prevent them from going even a step further. With this said, I think the next thing I'd like to speak about would be how best do we prevent this from going further? If we know that there is a possibility of our environment, our control plane being taken over. Remember, this talk is majorly focused on the control plane. So we're more concerned about making management level changes, create, modify, authentications. What if these control planes can be maliciously moved or someone can have malicious access to them? What do we do about it? How do we ensure that these services are not, we do not, we're not negligent, I would say, because we have designed it. And remember, things change every now and again. And as such, we need to focus on how best to make these changes. So I'll go further and talk about okay, I spoke already about how control plane breaches happen. For example, a GitHub secret leaks, the service principal is taken. Whoever leaks that secret, whoever has access to that new secret, and that secret is still valid. Remember, it stays for a period of time. That person can have service principal sign in. They can sign into ARM, have ARM API access. This ARM here will be Azure Resource Manager API access. They can escalate their access that they have, and now the new owners can then, I'll call them new owners, but instead the malicious user who is now the new owner of that access because they've escalated the permissions, they've gotten the secret, they are now able to make environment level changes. They can take over your entire environment, which is something we are trying to prevent. And for that reason, we want to look at how can we ensure that these breaches do not happen. We know the risk, we see the possibilities, we see what can happen. How do we ensure that we prevent users from making this level of changes? So I'll go one step further. This is basically explaining what I spoke about earlier. The your development environment, how these changes can happen, how users can unintentionally leak secrets, and how this privilege can be escalated, and people or attackers can make instance level changes or landing zone level changes. I'll just walk you through this environment quickly. Imagine this is you or me, the developer in this instance, and I'm deploying things. I have an SSH key. These are extensions of my Visual Studio Code and things like that. But remember, first thing is I'm using a network. Means that someone could hack into my network and all, but what nobody's doing that right now, assuming. We have vulnerabilities that we don't have control over because we're using third-party extensions. Now, you see that there are so many entry points that we have to safeguard about. We go further, we talk about we're making use of secrets, we're making use of secrets from our APIs, from our access tokens and things like that. These secrets are put in the pipeline to ensure connection between our development environment, our CI/CDs, our infrastructure basically, to our Azure environment, which we then deploy our landing zone, we manage our application, accept services, accept changes. Basically, our entire environment is within reach. But realize that this distance between this extension and this environment is just having access to these secrets. And this is why the control plane is very important. Whoever has access to this dev environment can escalate permissions and have access to our landing zone, which is why we have to be very compliant with DevOps. And so our DevSecOps, which is exactly why security was brought into the DevOps practice in the first instance. But we'll leave that and we'll go a step further. I see time is quite running real fast. So I'm going to try and just not take too much time on all of this. But I believe this is quite explanatory because I spent more time explaining it in the previous slides. So we'll go a step further. Where does zero trust come into all of this? In the first instance, what is zero trust and why is it important to implement? Zero trust is a security strategy. It is an approach to design and to implement security practices. The major security practices that zero trust is focused on is one, verify explicitly, two, use least privilege, and three, assume there's a breach. Assume there is a breach, meaning that with everything you do, assume that someone has access to your environment so that you're able to reduce the blast radius and your environment is broken down into small segments, and we're able to then define what changes are made on each of these environments. With that said, I'll go one step further and talk about verify explicitly, use this privilege, and assume breach. Verify explicitly is saying that for every action that is happening on your environment, especially on your control plane. Remember, I said there's a data plane and the control plane, but I'm focused on the control plane now. For every access happening on the control plane, make sure authentication and authorization is done for all data points. We'll go a step further. We'll go back one step. On this diagram, you see that between this dev instance and this GitHub repo, there should be constant verification. Why am I using secrets that are lasting so long? Why am I using secret pipeline approval processes that have the likelihood of a malware intrusion? For every action that happens, there should be segmentation, there should be um, authorization process to say that should this environment be able to deploy directly to production? Should this branch have access to make that kind of production level change? If yes, who is approving it? If yes, who is authorizing it? Who has reviewed it? We go one step further and say between the developer, his system, and the DevOps pipeline, how many levels of authentication do we have and how frequently does this happen? Right now, okay, but I shouldn't speak out. Just say that on the next slide, but we'll go for that. I don't say the next slide before we get to the next slide. Another thing to do is to use least privilege access. Ensure that your environment has least privilege always. Users should not be given access more than what they need. They should always have just enough access or just in time access, meaning that PIM access, users should only have what is required to do their regular jobs. If they then now need more access, then they can go to PIM, Privilege Identity Manager, and request access or get access that they're entitled to and make those changes. Next thing also I would say is to assume a breach. This is for me, this is like one of the key things. Always assume a breach. Segment your environment in the sense that every environment has a gate to it. I'll go back one step again and say, notice this is broken down into one, two, and three. These are three different environments. They are gated, they should be gated in their own ways. The landing zones, the subscriptions, the network, the services that consume these services should be segmented in a way that in the event that there's a compromise on one service, that compromise should not go further than a specific limit because we have segmented the entire environment. So always assume the worst, that there's a breach. Because there's a breach, we reduce the blast radius, we verify end-to-end encryption always, we use analytics to get visibility, we drive threat detection using things like Sentinel and others, and then improve our defenses. Now, this defenses here is what our on-premise environment was focused on. Our premise environment was focused on ensuring that we were more defensive, VPNs and firewalls and things like that. But now we are being both offensive and defensive, and even being middle in the sense that we are segmenting the entire environment and ensuring authorization from every step to the other. Now we go to zero trust principles. How are they applied to the control plane? If we remember that the control plane is the part of the cloud or of Azure where ARM level changes are made, Azure Resource Manager level changes are made, management.azure.com, which is what we call when we do our API calls, when we do our Terraform calls, when we do our CLI calls, when we do our PowerShell calls. That is the control layer we're calling to say, make this level of changes, delete this service, create this service, modify this service, grant access between this service to this service, and things like that. But imagine it is not being done from a human identity, it is being done from a machine to a machine. You see that MFA is taken out of the picture. And because MFA is taken out of the picture, we need to be very careful to ensure that we consider every angle of it. So I'll speak about this from the different side of it and verify explicitly. I'm going to say most of this, or basically define all of this based on the environment in itself. Yeah. So from the environment itself, remember a key thing: verify explicitly. So every request should be verified because now identity, from what I've said so far, you see that the key recurring factor is identity. It is connection between service to service. We're not even looking at the network layer right now. We're looking at the identity, who has access to what, who should have access to what, who can make changes to what, and who should be able to make changes to what, if they can, for how long, why, and things like that. Is this change being recorded and things like that? For that reason, we should consider things like conditional access for ARM policies. So conditional access in this instance would then be, we all know what conditional access is, tying access to where they are, who they are, when they should be able to access services. Are there specific IP addresses that should be allowed? Are there regions that should be allowed and things like that? But conditional access for ARM, basically, this would say before you can make ARM level changes, you should have conditional access to review where you're coming from, who you are, and what level of access you have or should you have. That's one. Second is privileged identity management. Like I said before, PIM. PIM is more or less ensures that we have user level access restricted to certain things, and then the global or the control plane permissions are then tied to privileged identities. So not everybody has control plane actions. Like remember, I said initially that control plane actions or control plane identities or control plane roles are things like owner roles, things like contributor, things like any change that allows you to make, delete, update, and make all those changes. You are not consuming resources. You are making instance level changes. That is a privilege. That is a control plane identity or control plane permission. And so for those kind of permissions, it should only be accessible through PIM, meaning that I shouldn't have owner role to the subscription. You shouldn't have owner role to the subscription. We should just have maybe, assuming I'm the application developer, I can maybe the DevOps operator or something, but ensure that when I then need privilege identity to make privilege change, I then need to go and make a PIM request. And that PIM request, very importantly, has to be reviewed. Someone has to have justification. You have to have a justification. This is why I need to make this change. If I'm making this change, who is reviewing this change? Who is giving me access? Who's granting access? It shouldn't be a seamless process, because if it is, then it means if someone does have access to my identity or to any identity basically that has control plane access, they can just go and request control plane access because it is an eligibility for that user. But that's like your idea. Then continuous access evaluation. This is key. We should always log everything that is done. For example, we have activity logs here. These activity logs should not be modified. It should not be something you just delete. Well, we have like laws that we say, rules that we say clean up after 6 months. We shouldn't do that. Instead, we should have like a container bucket, a storage bucket, and what that bucket should do, or what that storage account should do rather, should be store non-modifiable contents of your identity, of your what's it called, evaluations, like your log analytics, whatever it is. You should also be sending to a non-readable instance, so that in the event that there's any modification done on the other side, that storage account holds the actual data of what changes are being made. That is usually always typically for users. Then we move to least privilege, shrinking the attack surface. In this instance, we are trying to make sure that in the event that anyone is trying to get access to our platform, we are trying to ensure that we restrict the possibilities to the barest minimum. For example, if you have 10 owners on an identity or on Entra, 10 what do you call it, 10 global admins on Entra, it means these are 10 access points for an attacker. Let's shrink that. Let's take it down to the barest minimum. Maybe have just one global admin, and that global admin should be a break glass account somewhere stored securely. And then everybody that requires that level of access should always go and request PIM. Should always go and request PIM, and then PIM being approved before they can then get access to it. Also, clean up your environment. When people leave the organizations, are the environment actually cleaned up? Because I know I've been in different positions where I've seen that you have, if you look at your identity, your permissions list, you see this user doesn't exist anymore, and things like that. We want to make sure our environments are clean. We want to make sure that we don't apply permissions to individual users. We apply it to groups, so that, for example, DevOps group, administrative group, business group, and all of that. So that when we apply these permissions, when a user is removed from those groups, we're able to manage those permissions seamlessly. Harden service principal permissions. Now, for this, we can start using things like federated accesses, because service principals are beautiful, but it means that we have to manage secrets. You have to manage tokens. You have to manage certificates, whichever ones the access tokens are, the private identities are using. But we want to prevent things like that. So we're hardening our environment by using things like federated identities, federated service principles. If you use the federated service principle, it uses OAuth 2, and it means that there's only one validation done, and you do not need to manage those identities yourself anymore. Things like also manage identity services. I'm not manage identity principles or something in Azure. It allows you to create an identity and not have to manage it manually. Azure does the managing, does the secret tuning and all of that. That way you have less access to the environment in itself and make those level of changes. Assume breach is always happening. If you assume a breach is happening, then you start considering things like federated credentials over client secrets. I spoke about the similar here. Federated accounts over service secrets, because like I said initially, the service secrets can be accessed across different services. We are copying it initially, like those secrets are actually exposed one way. You are copying it, you are saving it somewhere. And because you are saving it somewhere, we don't know who has access to that environment. We don't know who is viewing your services. We don't know how secure your device is and all of that. So we want to make sure we try to use federated credentials where we don't have to manually always review client secret and all things like that. Pipeline permission boundaries, like I showed initially in that other diagram. Pipelines should be segmented. You have a pipeline for dev, you have a pipeline for and dev, prod, and test. You have different branches that deploy to that environment. There should be gates between each of these environments. Somebody should approve these gates. Things should be set in place to review to make sure that in the event that these changes are being made, are we secure? Are we sure that it is who we expect to make these changes that are making these changes? So next thing I also look at is manage identities for Azure hosted workloads. Manage identities, like I said, is more focused on Azure workloads, machines talking to each other, services speaking to each other, workloads being hosted across services, and all of that. And so when we look at manage identities within Azure service itself, it means Azure does the management of these identities, as against using service principles where we have to manually always change your secret, always change it. That secret in itself is where the problem is. If you notice, I keep saying the secrets. Those services is where the problem is. And because the problem is there, it means that access to those services can be taken maliciously. Someone can be viewing it. We don't know exactly everything that's happening. So we have to assume, like I said, assume the worst, assume that someone is actually doing this. And if we know that, then we're going to always want to harden our identities, our pipelines, and things like that. So we go to still on the control plane, we look at how do we mend boundaries for the APIs that speak to the control plane. Services that speak to the control plane are DevOps pipeline, things like that generally, CLIs and all of that. How do we make sure that these services are secure, these endpoints are secure? For me, the most important thing would be to ensure that only private services can make connections to your environment or to your control plane. How do you do that? By enabling private endpoints for ARM. If you are, well, I know all of us are very familiar with Azure, so I'd say this. I don't have to go too deep. Private endpoints, we know what they are. They're like more or less giving an extension to your network within the Azure space, and ensuring that for this time, doing it for ARM means that deployments can only happen from your local network. Meaning, I cannot just make CLI calls from any system. I have to be VPN into the environment. I have to be connected to the network in itself. Azure policy for preventive controls, we have to consider policies. We know policies. Everybody knows that we have to set specific policies. You cannot deploy certain services. You have in the event that a malicious person is trying to make a deployment, because we have specified parameters that work for us, means that we'll be able to spot whenever anything changes within those parameters. And so we have specific policies on what can be deployed, what cannot be deployed, what changes can be made, what changes cannot be made. All of this can be done using Lighthouse or Azure policy in itself and all of that. We know most of these ones. Resource lock, as minute as this sounds, remember only whoever has control level instance or control level permissions can make deletion on resources, can remove a resource lock that then allows you to make a deletion. Meaning that if I'm the owner of a resource, if I'm like the owner of a subscription and I lock a storage account, nobody else can delete it because I'm the only one that has that permission. I'm the only owner in that role, except there are other people with contributor or owner access, then they can do that level. That's why I said those access to be streamlined to PIM and specific people, and also activity logs, so that in the event that any of this happens, someone removes that log, we know who removed the lock. We know there's an alert that this lock has been removed, and we know why they removed the lock. Another is continuous verification and detection. Activity logs as a foundation. I spoke about this already. We need to continuously verify. So if you look, well, if you remember when I spoke about what are the key things about zero trust, assume that there's a breach, secure your environment based on activity logs, and also consider that authorization and secure authorization for your environment. On that same front of verification and detection, this is where analytics come in. Who is accessing what? When are they accessing it? How are they accessing it? We need to have activity logs, just like the base. Then we have key detection signals. What do you consider to be very important? Deletion of the source log. As silly as that sounds, is a very big flag. Who is enabling PIM? Who approved the PIM that has been enabled? What changes are being made? A pipeline has been deployed, something failed on the pipeline, something was designed on it, was pushed on the pipeline, a new branch, a new merge was made. Who made the merge and things like that? Those permissions, those level of activity tells us when things are happening, so that whenever it then happens that at odd times we see, for example, in the middle of the night, we don't expect anything to be happening, and then we see an activity log or even an email alert sent that this happened in the environment. We know something that shouldn't be happening is happening, and we can react as required. Key detection signals, we already spoke about that. What do we consider most important in our detections? What do we consider to be very important key signals for detection? Sentinel for control plane threats. So we know what Sentinel is, which is more like Azure's own control. I would say Azure's own security control parameter that allows us to run playbooks based on different scenarios, allows us to review specific actions, gives us alerts, notifies us on changes and things like that. I'm sorry I'm going so fast. I feel like I've spent so much time explaining the attacks themselves. But Microsoft Sentinel for the control plane threats. Control plane threats, remember control plane is based on ARM, ARM specific resources, authorization specific resources, policy changes, and things that we need to know why this has happened. If it has happened, are there specific actions that should be carried out within the organization or with specific playbooks and things like that? So that goes on verification and detection of systems. Now, the major problem every time I've spoken to people or maybe organizations around zero trust is always all of these are nice, but how do we deploy or put in all of this without slowing down production, without slowing down our pipelines? Yeah, you always say add gates, make these modifications, ensure that we have extreme gates for checking telemetry, who is doing what, somebody needs to access it. But how can we do all of this and not slow down the process from time to deploy? And then the key things I always say is this: automate your controls. If you're able to automate things, it makes it very seamless. We don't need an individual to review it every time. We just need to be ensure that we're following specific thresholds, we're following specific systems. Use infrastructure as code. It also goes to automating things, Terraform, Bicep, and things like that. Now, what I really like is building golden paths. Before even all of this, we have set in our environment, well, you should have set your environment to say that this is what we accept. This is our pipelines. This is how our pipelines should be deployed. Moving forward for the next, let's say, 3 years before there's a review, or if there's even a review next 6 months, these are the kind of things that should be deployed in our pipeline. So we know our pipelines are pre-hardened. We know our pipelines follow specific policies. We know our pipelines follow and contain specific gates. We know our pipelines follow and contain specific zero trust pipe paths that ensure that all these key things are considered. We are building or we're designing our templates as that there's telemetry being considered, log analytics and things like that. There is security gates in it. There is verification and authorization consistently being reviewed. How is this verification being applied is a very important thing also. All of this should be considered. And if we then, because it takes a while to make all these modifications or to make all these considerations, once we have made those considerations, we have put them in writing, and when we have applied them to a pipeline or to a template, it means that every time we deploy this pipeline, it is easy. We don't have to rewrite or reconfigure those templates or those pipelines. And for me, this is one of the best parts. So then integrate this policy as code into your pipeline. Policies means that what can be deployed, who can be deployed, what access can be given within the environment. We can define this in policies and ensure that those policies apply to our pipelines so that anyone that is very familiar or common is that you see they say you cannot deploy specific resources in specific region. You cannot deploy resource, for example, a virtual machine with a public IP. You are not allowed to run a Kubernetes cluster in this service or in this account, or this service account should not be called by this service and things like that. Those are like integrated policies that allows you to do specific things and make specific level consideration. And one very important one is always educate your team on why these controls exist. As developers, as DevOps people, as infrastructure engineers, we have the tendency to ignore things because we feel this is slowing me down. So how best do we design it? How best do we, no matter how good you do it, if the users don't understand the policy or the reason for it, they maybe will go against it, and which could always then eventually lead to an issue. So your users, your team, your DevOps, everybody literally has to be involved. Everybody has to understand why this is important and how this should be reviewed. Very important thing before I yield the mic, I would say things to remember. Breaches do not start at the control plane. They start at the control plane rather, they do not start at the network. Network segmentation is beautiful, but the control plane is very important. That's why you'd notice that even now with our new VPNs and all of that, we are even incorporating zero trust into the VPNs so that you even have to do an extra level of authentication every time you run within the VPNs. So that also goes to tell you how important the identity perimeter is and how access to control plane should be managed. Identity is your perimeter. MFA, conditional access, and privileged access management are very important tools. They have been applied now to every aspect of the cloud, to your networking, to your data, to your application, and all. But also, we should never forget applying those level of changes on the control plane itself, because the control plane is where resource management is happening in the Azure portal or in the Azure environment itself. Policy is there to enforce your baseline, not human behavior. When you have your policy set up, remember, like I said, your policies are there to guide your deployment, guide your environment in itself automatically. You do not need a human to review to say this is wrong or this is right. And very importantly, log everything, detect your anomalies, automate your response, always assume a breach. Zero trust and delivery speed coexist. Automation makes control invincible. If you are able to apply zero trust and you're able to still consistently run at speed, it means you have a secure, scalable, fast running environment, which is what everybody or every organization is trying to achieve right now. Service principal secrets are a liability. Use OpenID Connect and manage identities. This is one key one we all can start looking at right now. When you get back to work on Monday, when you get back to the office, when you get back to your lab environment, look at your service principals and consider how frequently are these secrets changed. Why is it that every time we do this, we have to break the environment because the secret expired and we're not ready for it? Or we have to set up automations to monitor secrets. Why don't we just use managed identities or use OpenID connects between services and ensure that we're able to make connections consistently safe and sound without breaking our environments and things like that? Thank you so much for your time. I know this is quite a lot, but thank you so much for having me. Have a wonderful day. Um, Hi.
Thank you very much, Moses. Hi, thank you very much for that wonderful section. Can you hear me?
Yeah, yeah, I
Okay.
can hear you clearly.
So that was very great. That was a great section, and I really enjoyed it. And I hope all our audience also enjoy it. Thank you for sparing us the time. I know time is very expensive, but you make it to be here today. Thank you. Okay. Hi, audience. Thank you for listening. If you have question, Moses is still here. And just before we wrap up the section in about 7 minutes from now, I would like you to, if you have a question for Moses, you put it in the chat so I can bring it forward to him. Also, if you have question maybe after this, just drop the LinkedIn for profile for Moses where you can reach out to him. You can connect with him privately if you need further clarification. So you can connect with Moses. He is available for you to connect with you. And also, our series continues next week, and I hope to see Yes, your screen was being seen. We saw your screen,
Okay.
Moses. So for the audience, we hope to see you next week. We hope to see you join us, and we hope to see you engage with the community on our social media pages, the the LinkedIn page, and also for the YouTube. This recording is going to be available on demand, so you can always visit our YouTube channel to watch. In case you miss it, you can also catch up with all this on our YouTube channel. So thank you for your time, Moses, once again, and also thank you to all our audience. Bye for now.